Today we're going to talk a little bit about inverse variation and kind of what that means. I want to remind you guys, back in Algebra 1 years ago, you did something called direct variation, so y equals k times x. And if you remember, you had to solve for k every time. They would give you an x and a y value, you'd solve for k and rewrite your equation. And so that's our direct variation. And we would read this, it says y equals kx. What we read, when we read this, we say y varies directly as x. And so the verbiage can be a little bit strange for some of these variation problems: inverse variation, direct variation, joint variation, some things like that. So let's talk about, like in words, what we're saying. If y varies inversely as x, if there is some non-zero constant k such that x of y, x times y, is equal to k, or y is equal to k over x. And this says where x is not equal to 0 and y is not equal to 0. So that's what we say in words, and this is our meaning. And really, this is, like, for me personally, my preferred way to write this. The way that we went from here to here is we simply divided both sides, not by y, but by x. Let's try it again, by x, and got y equals k over x. And so now that's it. So if you see y varies inversely as x, you immediately need to think, oh, y varies, I have to have that constant of proportionality, y varies inversely as x, and that's it. This is going to be our equation that we will use again and again. Sometimes our variables, our y and our x, will change. The k is always there, and we always need that k as that constant of proportionality. And then this is just an example where they gave us the constant of proportionality, and we have this variation. So x times y is equal to 2, and then they want us to do something with this, but it's not like super clear what they want us to do. And this is kind of how these problems work, right? They give you this equation, y times x is equal to 2, and x equals 6. Then y equals 2, 6. And so you're solving and kind of working your way backwards, right? If x equals 6, whoops, let's try a different one. If x is equal to 6, we have 6y is equal to 2. If we're solving for y, I would divide both sides by 6, and we would get y is equal to 2 over 6, or we have to reduce that to 1/3. And so just kind of working our way around. And with this inverse variation problem, it's a little bit interesting. If we have y equals k over x, right? As x increases, so that means as this x value gets bigger and bigger and bigger, that means my y value is going to decrease. Remember, k is a non-zero constant. And so if it's a constant, that means k is not changing. So as x gets bigger, my k value is not changing. We're dividing a fixed value by a bigger and bigger number. That means y is getting smaller. And consequently, kind of going the other way, if x gets smaller and smaller, then my y value is going to increase. And so that's kind of how we set these guys up. There's really like 3 parts to these inverse variation or direct variation problems. And again, here they have k equals y times x. My preference is for y equals k over x. So we have to create the equation with the constant of variation, and they're never going to come out and say you have to like create this equation with k, and then you have to solve for k, and they're never going to say that. This is just part of when they say if y varies inversely as x, and they give you more pieces of information down here, you have to go back and do that. So kind of what's going on. Once we do that, then we're going to substitute that k value and the remaining x value into the inverse variation equation, and we're going to solve for the missing information. And sometimes they'll give us a y value, sometimes they'll give us an x value, but first we have to create our own equation. So when we read this, let's look at example 1. When we read this, we see if y varies inversely as x, so that means y varies inversely as x, and that's how we read it. Y varies inversely of x. This is how we write it. And so then they say as x, and x equals 3 and y equals 9. So all we're going to do is we're going to change our x to 3, and we're going to change our y to 9, and we're going to plug these values in. And we're going to have to solve for k. And again, they don't tell us we have to, but that's part of this inverse variation problems. So 9 is equal to k over 3. And we're solving for k, so I'm going to multiply both sides by 3. And we're going to end up with k is equal to 27. So we have solved for that constant of proportionality, and now we need to write an equation. So we're going back to where we started right here, and we're going to have y is equal to, we're not going to write k, we know what k is 27 over x. And then they're going to ask us some more information, right? We're going to read through here. And so this is like part 1 and 2. Part 3, then what is x when y is 54? So they want us to solve for x when y is 54. So we're going to substitute a y value of 54 is equal to 27 over x. And we have to solve this. So I would multiply both sides by x, and that would give me 54x is equal to 27. At that point, I would divide both sides by 54, and I would end up with, let's do it right up here. We ended up with x is equal to 27 divided by 54 is 1/2. And so that's our final answer, and we are done with example. Jumping into example 2, it says if y varies inversely, so this one's going to be a little bit of a switch. Y varies inversely as the square of x. So this is x squared. It's the square of x. And it says when y is 20 and x is 4. So 20 equals k over, don't forget, this is 4 squared, right? And so we have to find our constant of proportionality. So I'm multiplying 3 by 4 squared, which is 16, right? 4 squared, 4 times 4 is 16. And so what we end up with is k is equal to, what is that, 320? So k is equal to 320. So what we have now is y equals 320 over x. From there, they're asking us, then what is y when x equals 5? So we're going to plug 5 in for x, and we get y is equal to 320 over 5 squared. I dropped a squared right here, you guys. Make sure you catch that. And so this would be 320 over 25, which is 64/5. And final answer. Example 3 is kind of a fun one, and I think it always helps if we label like x and y coordinate points first. And so it says it's an inverse variation includes the points. Well, here's our formula. It's inverse variation. Y equals k over x. It includes the point 4, 4. So that's an x, that's a y. And the points 1, comma, n. And so this is my x, and that is my y. And it says find n. So we have to take what they gave us. We have to take that 4, 4, and we have to plug everything in and solve. So we end up with y is 4, and that equals k over 4. Whoops, back up 1 second. I said y is 4, and then I wrote 4. I wrote y. We're going to solve for k. I'm going to multiply both sides by y, by 4, to get k is equal to 16. So my equation, y equals 16 over x, is our equation. Now, they're going to tell us that when x is 1, they want us to find n, which is a y value. That's a y value. Don't let the n confuse you. So y is equal to 16 over 1, which is just 1. And so they're wanting us to find this n value. I would leave it as y equals 1. That is a y value. So that's where we are. Let's turn the page. And now the problems are going to get a little more fun, as we say in math, more interesting. And so here's what we've got. The amount of resistance in an electrical circuit required to produce a given amount of power varies inversely with the square of the current. You could definitely use x's and y's for this problem. I would not. I like to make my variables match the word problems, right? So that my variables make sense. So here's what we've got. We've got resistance. The amount of resistance, so I would say R is resistance. And then I would say we've got power varies inversely. So power, produce a given amount of current, and we could say this a couple of ways. Current, looks like that's current, power is current. So I would say that C is equal to power or current. And current's a measurement, right? Those 0.8 amps. And so let's write our equation. The amount of resistance R in an electrical circuit required to produce a given amount of power varies inversely. So this is varies inversely, K over with the square of the current. So current squared, C squared. From there, it says if a current of 0.8 amps, so 0.8 amps, that's my C, requires a resistance of 50 ohms, that's my resistance R, we need to figure out what K is. And so R is 50, and this is equal to K over my current is 0.8 squared. So don't forget that squared, those amps are squared. We're going to multiply through by 0.8 squared so that we can get K by itself. That's going to reduce, and we're going to get K is equal to 50 times 0.8 squared, which is 32. And so we know what our constant of proportionality is. We know what K is. So we have R is 32 over C squared. So we wrote our equation, we solved for K, we found that constant, and now they want to know what resistance will be required by a current of 5 amps. So we're plugging in our 1/2 amp or our 5 amps for our current. We're trying to figure out the resistance. So R is 32 over 1/2 squared. And you can use your calculator for this. You could do it by hand. But this is going to be 128. And we should say the units. And so we know that our units are in ohms, OHMS, and there we go. One more and we're going to be done. So the owner of an electronics store determines that the monthly demand, so here they're telling us what variables we're going to use. The monthly demand D for a computer varies. So this is going to be D is equal to K over, varies inversely, with the price P in dollars of the computer. They say when the price is $700, the demand is 250 units. So we need to use those values and solve for K. So 250, that's our demand, is equal to K over 700. I'm going to multiply both sides by 700 so that those fractions clear. And we're going to get K is equal to 250 times 700, which is equal to, what is that, 175,000. That's a pretty interesting constant of proportionality. That's a big number. That's okay. We're going to get some big numbers with some of this stuff. So let's rewrite our equation. So we have D, the demand, is equal to 175,000 over P. And so they want us to find the monthly demand. They want to know what the monthly demand when the price is $500. And so what we're doing is if we know that we have this constant of proportionality, we can change our price, and that's going to influence our sales, right? If our price increases, our sales are going to go down. If our price decreases, our sales should go up, according to this equation. So let's see how many computers they're going to sell if their price goes to $500. So demand, the number of units that they sell, is equal to 175,000 divided by 500, and this gives us 300 units. And so we're going to sell 300 computers. So that is what our demand will be. And that is it for these notes for today. Good luck on your homework.